Hi everybody, it's Eugene Lisho here and welcome to Click 3D. This is the program where we talk about all things 3D, photogrammetry, laser scanning, and applications, all that sort of thing. So today what I'm going to be talking about are documenting bullet trajectories. And we're going to be doing that a couple of different ways. One is going to be through photogrammetry and the other way would be through some form of laser scanning, but I'm thinking primarily with the terrestrial laser scanner. Now obviously, unfortunately, crimes happen all the time and gun crime is a big deal, so investigators are going to find themselves in cases where they're going to have to deal with trajectories. And the trajectories are important, right, for determining where a shot may have come from or aligning wounds through a victim path or something like that. So there's a lot of benefits to knowing a good trajectory. And so there's a whole bunch of information that I'm not going to get into in terms of like placing rods and cones and all this sort of thing. So I'm just going to really talk about the basics and then get into the kinds of things that we use, or the kinds of tools, or you can see I've got a bunch of things in front of me that we would use for laser scanning or photogrammetry. So let me start with photogrammetry and how you might approach documenting bullet trajectories. Well, the first thing is that many people are often familiar with trajectory rods, and the rods are extremely useful when you have two impact points or two holes, and then what you do is you pass the rod through the two holes and that pretty much gives you a direction. Now you don't just use the rods themselves, but you also use centering cones, and so a typical centering cone would be something like this, and this particular centering cone is for this rod here. So the rods typically come in two sizes. So this is a 1/4 inch rod, it's about 6 millimeters, and this is a 3/16 inch rod, which is about 4 millimeters or so, just roughly. Now, they are different diameters, obviously, so the cones that you get for each one is going to be important. So on this rod right here, you have these larger cones. These have a 1/4 inch through hole here, and these smaller cones here, which are much more difficult to find, by the way, are for the 3/16 rod. And smaller calibers like 22 or 223, you would use the small rod, and then on the larger calibers like 9 millimeter, 40, 45 and up, you would use something like this. So those are the rods, and these are the cones. Now, when it comes to photogrammetry, the idea here is going to be that you take photographs of the rods, or you take photographs of your setup, and then somehow you're going to process those in photogrammetry software, and you are going to recover the direction of the rod. So there's some good things about photogrammetry and there's some bad things about photogrammetry. But the good things are that you can use just a rod. You can take photos of just a rod. It's very easy. The digital camera is readily available. Everybody has one. And so it's pretty easy in terms of equipment. Now, the downside to photogrammetry is that you often can't get really, really far away. So if you're documenting just a rod up close or a few rods, or bullet impacts that are close, no problem, it's usually quite good. But if I was to do a really, really large area over a wide space, then it's not really practical. So photogrammetry is meant for smaller distances or smaller areas. If you're just documenting a few individual trajectory rods or trajectories, then no problem at all, you can use them. And you can use it with just a rod, so as you're taking photographs of the rod, you can do just that, or you can have certain types of targets, and that's what I have over here. So one type of target that you can use on the rod would be spheres, and there's different types of spheres. I'll talk about them a little more on the laser scanning side, but I have two sizes here. The larger one is an 80 millimeter sphere, that's this one here, and then the smaller one is the 55 millimeter sphere. And so many programs now will have sphere detection. So when I take a number of photographs, what I can do is I can just outline or pick the sphere, and it'll detect the center of that sphere. And the great thing is, in all the photographs, no matter where you are, if you take a sphere, regardless of where I take the photograph, you can always determine where the center of that sphere is. So that's super useful and very, very helpful. And the idea is that if you place a couple of spheres on a rod, what we want to do is basically find the center of this sphere and the center of this sphere. And basically they will coincide with the center line of this cylinder, which is the trajectory rod. So 2 points that coincide and I'll be in good shape. I can basically determine the path or the same thing that's where the trajectory rod is just by using the spheres. So that's pretty good. Now the other thing that you can use, or the other type of targets you can use, well, there's several different, but here's another type. So this is a type of target that's used using April tags. And in an upcoming video, I'll be discussing more about what these types of targets are and even different types of targets, why they're used and why they're useful. And these are just 3D printed. So, I mean, if you have a 3D printer or you have somebody or know somebody that has one, you can use your imagination and come up with all kinds of different types of things. But basically here we have 2 targets, and the center of these 2 targets here, we can determine what those are through the software. So we have a center point and a center point. If I connect those 2 points, that line will run through the center of this point. So the midline of this line is right through the center of this trajectory rod. That will coincide with the center of this particular target here. And the center point there should align with this trajectory rod. And so it's pretty easy. You can put it on. You can put this on the trajectory rod, take photographs, and then instead of trying to detect just the rod, you can detect where these targets are. So that's useful as well. So there's a number of different things you can do when it comes to photogrammetry, but one of the downsides of photogrammetry is that it doesn't have an up direction, meaning that it doesn't know which way is truly up. So in a device like a laser scanner, you have what's called an inclinometer or some kind of leveling device. It will tell you quite accurately which way is up. So if I want to measure the vertical and the horizontal angles of this trajectory, then I need to know which way is up. So when it comes to photogrammetry, basically we need to put up targets and we can determine what the angles are relative to a surface. So in this case, I have a number of these little coded targets. And these are targets which are from a program called Photomodeler, and they're unique. But basically I could connect these all, or just a few of them, make a plane, and then I can determine which way these rods are oriented to that plane. Now another little thing that I've come up with here is there's this little device here. So it's just 2 spheres and they're basically a plum. It's basically a plum that's hanging off of the rod, and it's free to move, so I can move it around side to side or this way as well. So basically if I let this go, eventually it's just going to level off. And once it levels off in the software, as you know, I just talked about picking spheres, I can pick these 2 spheres and tell it which way is up. So it's basically a special type of Plumbob that gives me an up direction. So that's basically the photogrammetry way to use rods and spheres and different types of targets. So now let's talk about the laser scanner. So the laser scanner has a different principle. So it's not taking photographs per se to determine the 3D position of the rods. It's actually using a laser. So there's some side effects in using the laser, and there's some other things you have to think about. Just like in a camera, in photogrammetry, if you move farther and farther and farther away, you basically get less and less and less resolution. Now, when it comes to a laser scanner, the farther and farther away that you get, you have less and less points on an object. So it's important that you have to recover as many points as possible. So let's consider a few different scenarios. One is I'm scanning and I'm only using a rod. I'm just going to scan and I'm going to hope. So I didn't have these spheres on here. I'm just going to scan this and I'm hoping that I'm going to recover points along this sphere. Well, there's something called edge effects, and what happens is that the laser that's coming out of the laser scanner is 2 millimeters or 3 millimeters, but it has some width to it. So you run into a situation where part of the beam hits the rod and part of it misses. And so there's often some confusion in the instrument as to where the surface actually is. Now when the laser hits a perfectly flat wall, it's no problem. The signal hits and then it comes right back. But what happens if you hit a partial surface? So half of it hits the surface here and then half of it misses. Well, then you run into a problem. Sometimes you get some noisy points on the surface, or you get some what are called edge artifacts. So just using a rod like this, or worse, a smaller rod. So you're going to have less points on this rod, and potentially you could get a significant amount of noise. So what that means is, or the way to correct for that is, you just have to scan at a very high resolution when just using a rod. Okay, so that's one thing that's really important. So scanning at a high resolution and not being far, far away. Now, a lot of scanners give you the ability to move farther away and then focus in on a little window and then scan at high resolution, which is possible if you want to do that. And that's one way you can recover some points, but of course there's always a limit. You can't be 50 meters away and expect to get these rods up close. So if you can be close and you can scan the rods, no problem. Now, there are spheres that you can use. So these spheres here are 80 millimeter spheres, and they have a 1/4 inch hole through here, so they can adapt very well to the rods here, and you just slide them on like this. And if you're using the smaller rod, well, these 1/4 inch holes are not going to work for you because it'll be too loose. So if I put this through here like that, you can see that, well, you can hear this, it'll rattle around, so it's not positioned properly. So for that, what we have, and I've 3D printed these, are these little adapters. And so these little adapters just go on the end, and they're really just reducers. So you just kind of put them on like that, and well, I'll just put one on here, but over here I actually have 2 of them here. And then when you put the rod through, the rod will go through and adapt to the smaller size, just like that. Okay, so I only got it on one end, but I would put it on both, and then it doesn't rattle around. So that's important. If you're using the smaller rod and you've got the 1/4 inch hole, you can't put this on directly. You need some kind of a reducer to hold it in place. And these are just parts that I've 3D printed, but I don't know, maybe there may be a place that sells them. I'm not exactly sure. We talked about the cones, the centering cones, so they definitely do need to be used. So you can see here, I've got one on the front, and this is the smaller cone. So this cone is meant for the 3/16 rod here, but same idea. I've got one at the front and I've got one at the back here, which I'll probably show you in a video. And again, these are 3D printed and they're super useful, and we come up with little kits of stuff that we can put this together. Now, the other thing that's really useful too is, when using these spheres, if you have a very steep angle, so if you just put the sphere on here, it can be, it's a little loose, so it can kind of move. It has a little bit of play, but basically if you have a steep angle, well, you can see that the sphere will sort of drop down. So what we want to do is hold the spheres in place, and for those we have some small little O-rings, and so you put a couple of O-rings on. I'll just put it on one end just to stop it from falling, but basically you put it there and it stops. Okay, it stops from falling down. Now, what is the benefit of the sphere? Well, in laser scanner software, the sphere is usually a target that's easily detected, and it's also much larger than the rod itself. And the larger the sphere, the greater detection range you're going to have. So you can move farther back and detect the sphere. And so this is really useful because on the rod, I may only have, a few hundred points or something like that, if that. But on a sphere like this, at the same density, I could have hundreds and hundreds of points or thousands of points, depending on how close I am. And then what it's going to do is it's going to average the center of the sphere. So statistically, if I've got 1,000 points versus 20 points, 1,000 points should give me a really, really good center for this particular sphere. So that's why we use the spheres. They're automatically detected in software, or semi-automatically detected, which saves me a lot of time, because if I just use a rod, a lot of software will give you, you have to use manual sort of alignment. You have to go in and sort of in the software digitally move around a trajectory and try to get it to fit by eye as best as possible. So that introduces some subjectivity. Although there are some tools that I've seen from different manufacturers that will try to connect to a rod, I've seen it be hit and miss. It's not the best way to work. Sometimes it goes off in nowhere land and you're still stuck trying to manually align the virtual trajectory. So using spheres, big bonus. You get good accuracy, you get a good centroid, and it gives you some additional range to work with. Okay, so that is pretty much what I was going to cover with the spheres, using spheres, You can see here that I have it set up, and I'll give you a look at that. Now here's another little thing that we've come up with recently, and this is just a, I don't know what you call it, but just like one of these little arms, that articulating arms, and this is a magnetic base. And what we've done here is I've 3D printed a little adapter in the middle that allows for the 1/4 inch rod to go through. And when you put it through here, I can put 2 spheres on this. But the nice part is that I can put this on a surface and basically adjust the rod how I want. So like that, if it's a car body or something like that, I can just put it in and it stays in place. So in some cases, you don't have 2 holes where you can put the rod completely through. You may only have 1, or you may want to show a direction or whatever. So having this articulating arm with the spheres and the rod is super, super useful. And I'll run a little video where we just did some testing on this just yesterday actually. And basically what we're doing is we've shot a vehicle and we're testing to see how well we can reproduce the trajectories, or how accurate the trajectories are, based on something called a lead-in method. And we're laser scanning these to make our lives easier. And these devices here really helped quite a bit. There's also another version here that uses a suction cup. So if you're working with glass, or if you're working with some other smooth surface, this will even work on the side of a car body, but obviously you have to take more care just to make sure that it's not dirty or there's a lot of grime, so it does actually stick. So sometimes you just have to clean up the body. But on a metal surface, the magnet definitely will work really well. Okay, what I want to do now is I want to run a little experiment, because I always think that it's always best to do a little test, and then you'll be able to see for yourself why we would use something like spheres. So what I'm going to do is I'm going to take a few of these rods and I'm going to put them on a vehicle, and I'm going to space them out at different intervals. So maybe, you know, every meter or every few feet or something like that. We'll put one rod, we'll put 4 or 5 rods, something like that. And then what I'm going to do is I'm going to take the scanner on one end, and I'm going to scan the rods, and I'm going to scan the rods with a small sphere and then a large sphere on each end. And this way we'll be able to see how well just the rod is detected, how well the small sphere is detected, and how well the large sphere is detected. And I think that will tell you or show you why it's important to use these types of spheres. And I should also say that these spheres have been used in studies before. So there's a publication that we have out where we've used these before. And the good news is it really helps you with the analysis. There's no detrimental effect. There's no problem with the rod actually moving or whatever. In fact, not using them and using them statistically, they were about the same. They were almost identical. In fact, the numbers were a little bit better with the spheres, but statistically, you can't really say that. But the point is, there's no detrimental effect. They do everything to help you, give you more range, make it easier for use in the software. And I think they're a great addition to the kit. So overall, in summary, if you're going to be laser scanning or doing photogrammetry, and you're going to be doing bullet trajectories, with your trajectory kit, you should have an extra set of cones for the 1/4 inch cones. You should have some additional 3/16 cones. You should try to get yourself some of these adapters. If you want to, you can contact me. We can probably get you some of these. And also O-rings. You need to make sure that you have the O-rings to work there, and different spheres. Now, I will give a shout out to Koppa targets, so Koppa, and these are the ones that I've gotten from them, including these little ones here. And these little ones are new, so I don't even know if they're available on the website, but if you call or maybe harass Tad at Koppa Targets, ask him about these smaller spheres, because the beauty of these are that you can fit a lot more of these in a bag. So if you're traveling or you have a small case, you can get a ton of these in there, and they're super useful. And I'm finding that they're working just as well, and they're large enough that, you know, they give you enough range for most of the scenarios that I need. And if I really need to go with the larger sphere, then I can always throw these on as well. Okay, so I'm gonna set up for the test outside, scan those trajectories, and then we're gonna process them, and I'm gonna show you what we got. See you in a bit. Okay, so as you can see here, I've set up my vehicle, and I've got the trajectory rods, and I've got the 55mm spheres and the 80mm spheres, and I have 5 separate rods set up across the vehicle. So down there, I've got the laser scanner. And what we're going to do there is we're going to scan from that position. And so you'll see that there's a sphere and a rod that's close, and there's obviously the 5 back, there's going to be a sphere and a rod that are farther away. So we're going to choose a certain resolution on the scanner, and I only have to choose one resolution, but the point is here is you're going to see what happens as you get farther and farther and farther away from the scanner. And what happens to the rod, what happens to the small sphere, and then what happens to the large sphere. So we're going to go set this up, and let's see what happens. Okay, so we've got the laser scanner here. What I'm going to do is just check the settings. It's already set up. And what I'm going to do is go into the resolution quality. And I've got basically 1/5, 3 times. So the way that the resolution works is that if you bump up the resolution, I'm going to get dense points. Okay, I'll get a lot more points at a specified distance. And if I lower it down, I'm going to get fewer and fewer and fewer points. So the points are going to become more spaced out. So just to give you a good outdoor resolution with this particular scanner, it's also very common with other scanners too. It's 1/4 resolution, so it's basically just over 6 millimeters point spacing at 10 meters. So if you think about here, about 10 meters away, and I'm not sure if you can see there's like a mailbox down there, but basically, you know, around that distance, the spacing between the points that this thing's going to pick up is going to be about 6 millimeters. Okay, so something like this. So if we use 1/5 of that, it'll be a little bit less, okay? It might be like 7 millimeters or something like that. So let's just give it a go, and I'll just show you what the difference is like. So I'm gonna go ahead. There we go. I just shut off the colors on this one, so.
Like 2 minutes?
Yeah. That's it. Now I'll just take the data and I'll process it.
Okay.
And then I've got the data that we did yesterday, so I took some photos. So I may want to do photogrammetry with that one.
Sure.
So, but I can always add that in later if I want to. If I just show this, that's fine.
Yeah, that could be a good way. You can demonstrate the sphere tools on Zephyr.
Yeah, that's exactly what I was thinking. Yeah, so if I can reconstruct part of the body from yesterday, I can mark the spheres, and then I can import it into Zone, but I can import the point cloud and the spheres. So I should be able to export the spheres as an OBJ or as a DXF or something. Or unless they just come out as points. I'll have to figure that out. I haven't tried that yet, so we'll see. That was horrible. Almost there. Cool. I gotta do some of the B-roll stuff. Okay, that's good there. I'm gonna Okay, so that's done there. So what we're gonna do is we're gonna take this upstairs, we're gonna pull that scan, and we're gonna process it, and let me show you what we get on the spheres and rods. So give me a minute and we'll take care of that. Okay, so I'm back at my computer here, and before I go into the laser scanning data that we just captured, I actually want to show an example where you can use photogrammetry. Now, there's different photogrammetry software, and each one will work a little bit differently in how it might approach documenting the bullet trajectories, but I'm going to use 3ds Zephyr. And the other day I mentioned in the video that we were doing a student research project where we're using these type of supports for the trajectory rods, and this is just some images, and I've only got 5 images here, but I thought, you know what, I'll just give this a try and see what we can do here. So the reconstruction isn't going to be great, but I'll walk through the process. It'll give you an idea of how it works, and that should be good enough for the purposes of this particular video. I'm going to get into that right now and just get started. So I'm going to drag in these images. There are 5 of them, so I'm just going to go ahead and process these, and I'm not going to get into too much detail as to what I'm doing. I'm just going to use the default settings in 3ds Zephyr, and the first thing is to set up the sparse reconstruction. So it did that pretty quick, so I've got 5 images, and basically if I zoom out here, you see I just have a few points here, and there are these little blue things here, and I can actually increase those. So let me get those a little bit bigger for you so they look a little better. So let me go like that. Okay, so now you can see these little blue things. These are the camera positions, and it's looking at some of these sparse points. There's not a lot. There could be more, but no problem there. We're going to just go ahead and keep doing the reconstruction. So the next thing we're going to do is, I may have to do this twice because there's something called a bounding box, and I just want to see how much noise I get out of this because I can reduce that if I need to. So let me go ahead and see what we got here. This will take just a few seconds. And so now it's going to go in and it's going to get the dense series of points. And by doing that, it'll give me a better picture of the point cloud reconstruction. And then what I'm going to do after that is I'm going to go in and I'm going to mark the spheres. And that's one of the benefits of using the spheres. Okay, so I've got this reconstruction, but you can see it actually cut off some of what I needed here. Okay, so I'm just going to fix this very quickly. I'm going to level this back on the ground plane. So let me do that very quickly, just by picking a few points. Hopefully I picked the right amount of points. So it looks like it's level. That looks good. And then I'm going to go in and just check the bounding box. I'm going to reset that. That should actually straighten it out. Yeah, it's far enough that it's okay. Let me go to a top-down view. That looks all right too. And I'm just going to adjust the back here, get it a little bit in so I don't need all that. Okay. Good enough for here. I don't need to do much more. Just a little piece of the car. And we're going to go ahead and process that again as a dense point cloud. So I'm just going to go to dense point. Oops. Let me try that again. Dense point cloud. Go ahead. I could choose high details maybe. So let me do that. Just go ahead and hit run. And let's see what it gives us when we come back. Okay, great. That's done. Let's have a look here. So you can see the point cloud isn't all that great. I would have done some things here to fix some of this and get a bit more detail, but there is a bit of noise that I can see, and some of that I should probably clean up a little bit, but maybe for the example it's all right. Actually, you know what, I'm going to take a second here, just do a little bit of cleanup, and then I'll come back and we will then mark some control points or some of these spheres. So let me see what I can do here. Okay, so I've done a little bit of cleanup, and now what I want to do is mark a couple of the spheres. And fortunately, 3ds Zephyr has a new sphere marking tool in it. So I need to go to the ground control point menu, and what I'm going to do is pick this from the images. So I'm just going to do 2 of them, and I'll pick like this sphere and then maybe this sphere, and then we'll just export them or something like that and look at it in another program. But there's a button up here. Okay, this is the sphere marking tool. It's a new feature. So I'm just going to click and drag a window around the sphere. So you can see it did a pretty good job of matching that. And now I'm going to go and pick another one. So I got to go to another image. And this line here is called an epipolar line. And that's a guide. It kind of guides you and says somewhere along this line there should be a sphere. So I've got a couple of points now together, and now you see that it even has a little dot there. It says, hey, I think the center of the sphere is somewhere there. So let me try one more, and that looks okay for me. So I'm just going to leave that there. I'm not going to worry about the projection error for now. I'm just going to go apply, and actually let's just have a look at that. So you'll see when I zoom in now, you see that I've got this GCP, this ground control point, which is really just a control point. And you'll see that it actually ends up or lands in the middle of all those points. Even though they're a little bit noisy, from the images, you actually get a pretty good result there. Okay, so let's go do the other one. So it's this one over here. So same thing, sphere marking. I'm just going to go click and drag and see what we can get. Okay, that one's a little bit off. I don't like that one. So let me go like this a little bit, see if we can get a better result. It's off a little bit here. However, if I keep marking, it will adjust a little bit. So let me just go a little bit more. Or what I can do is just choose not to use this particular image. So, so for example, if I go here, you know, I could start it at another one, but I'm just going to keep using this one. And let me see what I got here. Maybe this one. Yeah, that one looks pretty good. Let me try this one here. This might help to straighten it out a bit. Okay, that's not too bad. I'm going to live with this for now. I'm just going to go OK. And now you'll see that I have two control points here, something like this. And maybe just for the heck of it, we need to apply some kind of a scale to this thing. So what I'm going to do is I'm just going to go to distances, and I'm going to choose that. I'm going to just say maybe the distance between these two is something like 30 centimeters or something like that. So I'm going to scale model here with these two control points, and I'm going to go 0.3. I'm going to go OK, and it says 0.3 here. So now that I've got that, what I'm going to do is just change this to meters. So get everything into meters and go OK. All right, so that's pretty much set. And what I'll do just for the heck of it is export this into another software package just to see what it looks like. So let me go ahead and export this now. So I'm going to export the dense point cloud, and I'll do that as an E57 file. I'm going to export this, and I'll do it directly on my desktop here, and I'll just actually, I'm going to do dense point cloud number 2. That's the one that I want, E57. I'm going to export this. I'll just call it, yeah, dense point cloud 2 is fine. I'll export that, and I'm also going to export those control points. So for that, I'm going to do those as a DXF, and I don't need anything else. So just the DXF. Again, I'm going to export these onto my desktop, and I'll call this control points. Actually, I don't name it there, I name it here. So I'm going to go save, and that's been successful. Okay, so what I'm going to go do now is I'm going to open up Zone 3D. We're going to import all this, and I'm going to show you that you can make a trajectory on the vehicle. So we'll make a new point cloud. I'm going to bring in the point cloud that we just did here. So that's this guy over here. And that's it there. So I think what I'm going to do is I'm going to shut off the I'm going to shut off all of these grids and stuff just so that it doesn't get in the way. So we've got this point cloud, and now what I'm going to do is I'm going to go back home, and I'm going to import the DXF file for the control points, which are these guys here. And for these, yeah, I want to merge it. And now this is in meters. I'm going to go OK, and I'm just going to go enter. So that should put the points right over here. And actually, I can just see them. There's one here, and there is one here. So that's useful for me. And what I can do is I can set up a trajectory now. So if I shut off the point cloud now, and you'll see that I just have 2 points here, and those are the 2 points. So I'm going to go ahead and just set up a very quick trajectory by clicking 1, by clicking 2, and I'm going to extend this out to show the direction that it's coming from, and then I'll just turn the point cloud back on. Okay, so there we go. So we have the trajectory, we've got a cone there, and you can see that it's following along the trajectory line. So if I look here, even though the point cloud might be a little bit noisy, those control points are much more accurate when you pick them from the images here, and you'll see this is what we've got. So there's other things we need to do here to set it up and everything, but I think this gives you an idea of how you can use photogrammetry to get the trajectories from the spheres. And the spheres are super useful because they are targets which help to refine, and I'm not trying to, you know, pick and choose the rod or trying to align something to the trajectory, which actually doesn't come up all that well. If you look back here, you'll see that in some cases, you see the rod is kind of noisy. And even over here, okay, this one's not too bad. I did okay there. But you'll see here, you're missing parts of the rod, and it just becomes a little bit more subjective when you're trying to pick these trajectories. So that's how you would do it with photogrammetry. Now let's go back into the data or start the data processing of the laser scanner. And I want to show you exactly what happens to those rods with the scanner. Okay, so I've switched over to Pharaoh Scene, and what I'm going to do is I'm going to create a new project, and I'm just going to call this Trajectories, and I'm going to go ahead and create. Now I have a scan file which I am going to import, and I'm going to need to process this. So what I'm going to be doing is just adding some of the colors and stuff like that to this data, and just put color, and that's all I really need. I'm not going to detect any spheres or anything like that. So I'm just going to go ahead and process. And what I'll do is, once this is done, is I'll bring it up and I'll just I'll focus in on just the data that we need. But I'm going to show you what the rods look like at different distances, because the rods are very small objects. They're not great for scanning, although you can recover them at close distances. They drop off pretty quick. You know, after a few meters, or you just don't get the data. So you have to either increase your resolution, or you have to get the scanner closer, or definitely use trajectory spheres. They're super, super useful, and hopefully you'll see why here in a second. Okay, so it's finished processing here, and I'm just going to have a look at the data and see what it looks like. So I'm just going to look at it in 3D here. I'll do it this way. Okay, so I've got obviously a ton of data here. I don't need all of this. I'm just going to narrow this down into the area that we're just focusing in on. So we're going to do this like that, and just tweak this a little bit, just so we can focus on what we need. Like that, and I'm going to get rid of the walls, just get into the data. Okay, so I do want to see where the scan position is, and I don't need the wall there. Give it another little tweak like that, and that looks good to me. So I'm just going to shut this off. Okay, great. So first things first, I'm going to shut off some things here, go to medium. All right, if you get in close here, you'll start to see what the data looks like. Now you can see the spheres. Now this is the closest one. That's the scanner position, and these are the spheres. And let's just look at the rods to start with. So you can see this rod here is relatively close. That's the first one. The second one drops off pretty quick. The third one, we get some couple of small pieces, and then we don't get anything for the third, for the fourth and fifth one. There's just nothing there. Okay, now we still get the spheres. And this is exactly what I'm talking about is, you know, when you get up close, you get really, really dense points on the sphere, and the spheres, just that little bit of the spheres picks up a ton of data, and the rods just disappear. So if I was scanning this at a scene, and I've got the scanner here, you can see that once I get to about this point here, I don't want to scan at about this point because I risk losing the data. So somewhere between here and here, right, I have a problem. Now we can look at some of the distances here. So let me go ahead and maybe do that. What I'll do is I'll start marking the spheres. Let me look at this in a planar view. And I'm going to need to set the sphere size here. So just give me a second here. I have 0.04. That's okay. So that's for the larger spheres. Let me go ahead and do that. So here we go. So I'm going to mark these larger spheres. Okay, and see what we got. So I've got a sphere there. I've got a, oops, just give me a second here. I've got a sphere there. Let me get up here. There we go. So I've got a sphere there. I've got a sphere here, and I've got a sphere there. So you'll look at these spheres. One thing that we can determine here is the distance between the scanner and the spheres, just so we have some kind of a metric, some kind of a ruler that we can check this with. So what I'm going to do is I'm actually going to take some measurements, and I'm going to say from the scanner to this first sphere, okay, it tells us that that's like 2 meters. Let's just do them all so we get some kind of an idea here. That's the second one, and I'll just give you all the numbers once I'm done. This one, and then the last one. Okay, so these are all the distances that I have where it says measure object, and they're in order here. So if I zoom in here, I can get all the distances. So the first one I can see is 2.1. Okay, the second sphere here, you can even bring it up by here, okay, is going to be 2.7. The third one is going to be 3.68. The fourth one is going to be 4.47. And then the fifth one is going to be, okay, 5.3. So somewhere, you'll see that somewhere between, okay, the third and the fourth one, we lose the trajectory rod. Okay, so somewhere between 3.6 meters or after 3.6 meters, we start to lose the trajectory rod. And so that's something that we have to keep in mind, right? We have to be careful not to scan too far away. Now, in terms of the number of points on the spheres, that's something that we can check too. So for example, on the first sphere, we can check how many points were detected. So here we have 1,596 points on this first sphere. That's very, very close to us. And that's super helpful. And on the last sphere, when you start going away here, if I click on this one, and I open this up, okay, you'll see that we have 177 points. So even though we're like 5 meters away, okay, we still have enough points on the sphere. Now, one thing in the Faro Scene software, if you fall below 80 points, you start to get a warning and says, hey, you're starting to lose points on a sphere. So you want to try and keep this into, above 80 or into the hundreds of points on a sphere. So this is good. So the distances that I chose are really great. So the spheres, I would have even more distance using the 80 millimeter sphere. All right, so no problem there. Now the smaller sphere obviously is going to have less range, but you can see even here, I still have, somewhere maybe around 80 points or something like that on this particular sphere. So it's probably right on the edge. But if you use this in Faro Zone or something like that, it's perfectly acceptable. Now let's look at something else here. I'm just going to get rid of all these measurements here, and just so that we'll clean this up a bit in the view. Now what I want to look at here is the actual trajectory rod. Okay, so if I start looking at the rods here, this is another reason. If you look at the sphere and the surface of the sphere, we get a very clean set of points. But if you look at the rod even up close and you look at it from the top down, we start to get some of these streaks here and some noise. And this becomes problematic as you get less and less points. And look, if you look over here, right, we get some streaks going off this way. These are some of just the artifacts that come off of the rod. The rod is usually when you buy the trajectory rods, they're a little bit shiny, they're small, you get the edge artifacts that I was talking about, and so up close, it's not too bad doing it subjectively. I could run a trajectory along this in Faro Zone 3D or a different piece of software, but look what happens here. We start to drop off and I'm not getting as much detail here. So this would be problematic, and also you get noise, same thing, just like before. If I go up top here, you see, like, where's the rod here? This becomes a problem. So this is where the spheres helps a lot. Look at over here. So here we're getting a little bit of noise. We're getting part of the rod. Again, becomes very, very subjective. Now, I could go back. Okay, now here they obviously disappear. Now I could go back and I could scan these at a very high resolution, and then, they would look more like this, which means that, I can recover it better or whatever. But why bother? If I've got spheres and they work well, then I really don't need to, run that exercise or do that. If I really, really need to, no problem, I can. But if I don't need to, then why bother? So these are a whole bunch of different reasons why the spheres are super useful. Now, I'd like to bring your attention to a study that we did a while back and that we published. And what we were looking at here was the accuracy and repeatability of the trajectory rods. And in this study, we did both the rods themselves and also the rods with the spheres. And what we were looking at or trying to figure out was, are the spheres detrimental? Do they cause a problem? Do they, put some weight on the rod and maybe shift the result somehow? And the good news here is, if I get right to the data right here, you'll see here that it says, and I can just read this, but it says to determine whether the spheres were beneficial or not, the error of the data with the trajectory spheres ranged between 0 and 2.16 for like a full set. And then we're using something called quartiles, so that at the 75% mark, if you were to look at all the data, okay, basically the value is 0.43. So at 0.43 is where 75% of the data was inside of. And you'll see the range is from 0 to 2.16. So 2.16 was the maximum value, and that's with spheres. Now, if you look without spheres, you'll see that we get up to, well, a couple of things. The first one is that the range goes up to 2.45. So we went from 2.16 to 2.45. So there's a little bit more error without the spheres. And that's probably because there's a little bit more subjectivity. Also, if you go back to the 75% mark without the spheres, we're at 0.65 versus 0.43. Now, we're talking about fractions of a degree here. So even though there seems to be a slight improvement with spheres, that's not the point. We can't say statistically that they are different. But the main point here then is, if you use the spheres and they give you all the benefits of, increased range and accuracy, less subjectivity, then it's a major point when it comes to doing trajectory rod analysis. It doesn't have any detrimental effect. And if anything, it may even be more helpful. So in terms of a best practice, I would say that using trajectory spheres where possible is extremely useful and extremely helpful. So that does it for this one. Thanks everybody for sitting through this whole thing. I hope this was beneficial, and we'll see you next time on Click 3D. Bye-bye.